Hello student, good morning. Today we will start the antigen antibodies of parasites and host. As immunity develops in worms infections, it is manifested by number 1 slower development to the adult stage, stunting of growth, inhibition of reproduction, premature expulsion of worms already harbored, first demonstrated by Stahl in 1929 in sheep infected with Haemonchus and term self-cure, and fifth, resistance to reinfection. These are all effects which might be expected if the immunity operate by interference with nutrition. Chandler in 1953. Acquired immunity. Acquired means to create the self. In protozoan infections manifest itself similarly by slowing up of growth and reproduction, and refractoriness to reinfection, and also by destruction of the parasites by lytic antibodies possible stimulated by body substances liberated from dead organisms whenever these antibodies have access to the parasites. Usually the parasites may escape. For example, early in an infection, Trypanosoma cruzi is abundant in the blood, but in the later chronic stages, only those individuals survive which quickly invade a new cell after being made homeless by the disintegration of the old one. Disintegration of old one. It is interesting to note that such worms as Trichinella and Nipostrongylus dependent for food on the intestinal mucosa, which would be expected to become saturated with antibody before there was high titer of antibodies in the blood, produce immunity much more quickly than blood suckers such as hookworms or Haemonchus. A similar local concentration and consequent local manifestation of immunity was demonstrated by Blacklock and Gordon in Gordylobia infections in the skin of Guinea pigs. Even when antigens are liberated into the general circulation, they may be stimulated more and be taken up by particular tissues. This might explain results obtained in parabiotic twins with Nipostrongylus infection by the writer 1935, with Trichinella infection by Jehman 1953. It may now be assumed that acquired immunity develops against all parentally located parasites, all parasites with a parental phase, even if it is only temporary invasion of the mucosa. Example, phagostomes and cysticercoids of Hymenopus nana, and parasites that break the mucosa sufficiently to inject antigens from the mouth while feeding as trematodes, and most nematodes do. The tapeworms and acanthocephalans are exceptional in that some of them at least fail to get any antigen inoculated into their host and thus fail to stimulate any specific immunity. And unique situations exist in the case of tapeworms. Hymenopus nana, which may infected its host either as eggs, in which case there is a parental cysticercoid phase in the villi, or as cysticercoid develop in beetles, in which case there is no parenteral phase and as might be expected. No specific immunity. Hahnemann 1954 showed, however, that immunity produced by an egg infections but also affects worms in the intestinal lumen resulting from feeding of cysticercoid. Importance in connection with development of acquired immunity is diet. Adequate protein of good quality is necessary for production of antibodies and phagocytes. Even a reasonably good diet may be inadequate if one or more of the following conditions exist: low protein, insufficient calories, poor vitamins content, growth in young animals or children, loss of blood or pregnancy with inadequate protein. Failure of immunity allows for unimpeded multiplication of parasites or continued acquisition of new ones, which further lowers resistance of the host and establishes a vicious cycle. On the other hand, one may go so far as to say that severe chronic nematodes or trematodes infections are probably impossible in a well nourished and otherwise healthy animals, except under conditions of very heavy exposure to infection before there has been time for immunity to develop. A striking demonstration of this was made for Foster and Cork 1932 and 1935, working with hookworm infections in dogs. In the writer's opinion, the level of infection with hookworms in a community, for example, is more a measure of the dietary conditions than it is of exposure to infection. The poorer the diet, the more severe the infection must become before protein is diverted to antibody production. The corollary of this is that to a large degree severe chronic parasitism with nematodes and perhaps many other parasites as well as is symptom of poor nutrition for most adult tapeworms, which do not stimulate antibody production. The nutritional effects are different. A good diet does not adversely affect the worms does help the host, permitting him to feed the worms, but does help to host permitted him to feed the worms as well as himself without injurious loss of protein and vitamins. Loss of proteins and vitamins. Tolerance to injurious effects. In the foregoing paragraphs, we have considered principally the immunity brought about the reaction against the parasites which results in their death or interference with their metabolism. In addition, however, there is a development to tolerance to the injurious products of parasites or increased efficiency in repairing damage done by them, which protects the host without injurious the parasites persons losing blood from hookworm infections place their blood forming mechanism on a plane of increased activity and efficiency. Animals exposed to injury by the toxic products of screw worms develop the ability to neutralize these products and render them less harmful, and persons exposed to worm infections increase the number of special white blood corpuscles called eosinophils, which are somehow concerned with the neutralization of injurious products of the worms. This eosinophilia is a very characteristic features of worm infection, particularly parental one's failure to respond parental invasion of worms, and an increase in eosinophils indicate that defensive mechanism of the host is not functioning efficiently. This is the antigen antibodies of host and parasites. Okay, thank you.